Hello, and welcome back. So we're going to continue our discussion with natural log and integration. So we're going to talk about what rational function integration. Now, all rational function really means we're looking at the degree on the function. For example, let's think about a number like this, like 5 over 3. This is what we call an can't spell improper. That is what we call an improper fraction. Well, we don't like that, so we're going to write this as a mixed fraction. I can write that as a mixed fraction by writing this as 1 and 2/3. We know to write this as a mixed number because the number on top is greater than the number on bottom. We can also do the same with fractions or variables, but we look at the degree. So if the power on top or the degree on top, we call it the degree, if the degree on top is greater than the degree on bottom, we are going to use a new technique. And I call this the top greater than the bottom, or sometimes I call it the BOT, big on top. And that's what we have here in our first example. Notice we want to integrate this 2x squared plus 7x minus 3 over x minus 2. The degree on top here is 2, the degree down here is 1. So to do this one, we are going to use long division to write as separate terms. Now you can use synthetic division here, but long division is much more applicable in the long term of things. So I'm going to divide. Now I know some schools teach the array method. That's fine. So here I'm going to get 2x squared plus 7x minus 3. So I'm going to take this 2x squared plus 7x minus 3, divide it by this x minus 2. So I ask, well, what do I need to multiply x by to cancel with x squared? And of course the answer there is 2x. Line up your variable. I'm going to put that 2x over my 7x. Multiply. I take the 2 times the x. We get 2x squared minus, this becomes 4x. Subtract. Those cancel. This becomes positive 11x. Be careful because it's 7 minus a negative 4. We have positive 11 and bring down that minus 3 right here. And I just repeat the process. What do I need to multiply x by to cancel 11x? And of course the answer is 11. Multiply x times 11, I get 11x, minus the x times 2, I get 22. And I'm going to subtract again. Those 11x's cancel. Negative 3 minus a negative 22, that becomes 19, plus 19. So we get this plus 19 over x minus 2. Once I'm at this point, now I can rewrite my integral. I have not taken the antiderivative, I just rewrote this as a mixed number. I took an improper fraction and made it into a mixed number. So this becomes 2x plus 11. Now I'm going to stop here, dx plus over here. Now I'm going to write my new part, this 19 over x minus 2 dx. I could write it as a single integral, but it's helped to write this as two integrals. Integrating over here, 2x just becomes x squared plus 11x plus over here on the next one, it's 19 over x minus 2. This is our u substitution. U will be x minus 2. Our du is dx. So this becomes plus the antiderivative of 19 over u, and I replace my dx with du, which is easy. This is x squared plus 11x plus, delete. There we go. Plus 19, the u's on bottom, natural log of the absolute value of u plus c1, and I just replace my u. X squared plus 11x plus 19 times the natural log of x minus 2 plus your constant of integration. Man, these are starting to get ugly. So, again, if I have a problem like here, like number 2, look here, the powers are the same. I'm still going to do the same. I'm still going to divide, okay? So I'm going to use my long division. I take this x squared plus, now there's no term in the middle here, so I'm going to add a 0x there. Plus 1, divide that into x squared plus x plus 1. And I divide. What do I multiply x squared by to cancel with x squared? 1. And that's where it goes, just 1 right there. I'm lining it up. Okay, it doesn't have an x to it, it's just above that 1. Multiplying, I get x squared plus 0x is 1 times 0, plus 1 times 1 is 1. And I subtract everything. X squareds cancel. We get x minus 0x, which is just x, and the 1s will wind up canceling because 1 minus 1. So this is my remainder. Now, I know it's my remainder because I can't take x squared and divide it into x. So it's my remainder. So this becomes plus x over x squared plus 1. So when I rewrite my integral, we get 1 dx plus, I'm going to use my remainder here as another integral. It helps to do it this way. X squared plus 1 dx. So let's see here. Taking the antiderivative, well, the antiderivative 1, that's just x, plus over here, we're going to do our u substitution. Let u equal this x squared plus 1. Our du is 2x dx. Dx is du over 2x. And I can rewrite my integral. X over u, look, your x is over u again, du over 2x, and the x's cancel. And what I'm left with is 1/2 1 over u du. Or x plus 1/2 the natural log. Remember, this becomes natural log, that's a new rule today, of u plus c1. Replace your u, we get x plus 1/2 natural log of x squared plus 1 plus c1. And there is our function of mathematics. All right, y'all try this last one real quick. Go ahead and pause it. Notice it's a cube this time. That's a little bit weirder. Okay, my guess is maybe I mistyped, but that's okay. Let's go with it. The power on top is bigger than the power on bottom, which is what we want. So when I write it, I'm going to take this x plus 5 and divide it into this x cubed plus, cubed. Let me rewrite that again. X cubed plus 0x squared. I gotta get every term of power there. Minus 6x minus 20. Quite simply. X goes in x cubed. How many times? X squared times. Line it up. X squared. Multiply. X cubed plus 5x squared. And I'm going to subtract. X cubes cancel. 0 minus 5. Negative 4x squared. Bring down that minus 6x. What do we multiply x by to get negative 4x squared? A minus 4x. Notice I'm lining up. X's are lined up. X squared are lined up. Negative 4 times x, negative 4x squared. See, they're going to cancel now, which we want. And this becomes minus 20x. Subtract. Those are going to cancel. Negative minus a negative 4. Negative 4 minus a negative 4. Canceled. Negative 6 minus a negative 2. This becomes minus 4x. Minus 20. Bring down that minus 20 there. And what do we multiply x by to cancel with this negative 4? Of course, it's a minus 4. And we get negative 4x. Again, minus 20. And let's see here. Oh, how nice is that? When you subtract, everything cancels. And we get 0. So notice, in this case, there's no remainder. So my answer, we're going to rewrite our integral as x squared minus 4x minus 4 dx, and there's no remainder part, so we don't have to worry about that. So my answer, x cubed over 3 minus 2x squared minus 4x plus your constant of integration. And there's your answer. So hope you guys enjoyed the video. Leave a nice message for me. Love you. Bye-bye.